Okay, let's have a look at this problem. There's a group of 6 men and 4 women. We're supposed to select 3 individuals to form a steering committee. And if the committee must include at least 2 women, how many ways can we form this committee? So the key here is that there has to be at least 2 women on the committee. And there's a 3 total, so that means we could have a committee where there is 3 women on there. That could be one possibility. That's at least 2 women. And the other way then would be to have 2 women and 1 man. Both of these committees have at least 2 women on them. Well, let's take a look at this one. How many different ways can this be done? Well, that should be pretty simple to answer. We have 6 women, and all we're going to do is select 3 of them. So we know how to do that. 6 women, choose 3. The order doesn't matter, so this will be equal to 6 factorial divided by 6 minus 3 is 3 factorial times 3 factorial. And this equals 6 factorial, that equals 6 times 5 times 4 times 3 factorial divided by 3 factorial. And 3 factorial itself is 6. So we can write it like this. Cancels here and here. And that equals 20. So there's 20 ways to form a committee with 3 women on it. Now, here we want to have another committee to take care of the other possibility. We have 2 women and 1 man. So you can think of this now as you're performing 2 tasks. First task is select the woman. The second task is select the male that's going to be on the committee. So task T1, select 2 women. And task T2, select 1 man. Then we consider, to get the entire group, we perform task T1, then task T2. The number of ways we can do that is the number of ways that we can perform task T1 times the number of ways that we can perform task T2. Okay, T1 is to select 2 women from 6 women. So this, the number of ways that we can do that is just C, 6 women, we're going to select 2 of them. The order doesn't matter. Here we're going to select 1 man from 4. The order doesn't matter. So the number of ways that we can perform task T1 is this, times the number of ways that we can perform task T2. That will equal then, this is the number of ways that we can perform task T1. This is the number of ways that we can perform task T2. Select 2 women, select 1 man. Multiply those together then using the fundamental counting principle, and that will equal the total number of ways to select 2 women and 1 man. This is just using the fundamental counting principle again. So let's see how these numbers work out. Here we have, so we don't need that anymore. This is just going to be 6 factorial. Divided by 6 minus 2 is 4 factorial times 2 factorial. And this is going to be 4 factorial. 4 minus 1 is 3 factorial times 1 factorial. Looks like those will cancel. This is equal to 6 factorial, 6 times 5, divided by 3 factorial, that is 6. 2 factorial is just 2. So this cancels, this cancels. This will go into there 2 times, and we have 5 times 2 is 10, times 30 times 2 is 60. So to perform or to select 2 women and 1 man to form our committee, that can be done 60 different ways. So let's go back to here. We can form this group 60 different ways, or could have a group like this. Either way, we have at least 2 women, and this can be done 20 different ways. So how many ways can we form a group that has at least 2 women? This plus this, or that would be then 80 different ways total. So there again is another pretty straightforward combination problem. Hopefully it makes sense to you. Let's see if we have enough time to tackle another one here. Let's say that we have a bucket that has different colored balls in there. Say we have 4 red balls, and 8 white balls. So we have 4 red balls and 8 white balls to choose from. How many different ways, for example, can we select 4 white balls? Obviously, the order doesn't matter. Well, here, of course, that's just going to be, we have 8 to choose from. We're going to take out 4 of them, so that would just be 8 factorial divided by 8 minus 4 is 4 factorial times 4 factorial. So let's see, this is 8 times 5, 8 times 7 times 6 times 5 times 4 factorial divided by 4 factorial. And we have 4 factorial again, 4 times 3 times 2. These will cancel. This goes into there twice. 3 goes into 6 2 times. So we have 2 times 7 is 14. Actually, these 2, those will cancel. So we have 7 times 5 is 35 times 2 equals 70 different ways that we could choose for white balls out of there. Okay, well, let's say that you want to select 3 white balls and 1 red ball. How many different ways can we do this? So here we're going to select 3 white balls. That's task T1. We're going to select 1 red ball. That's task T2. Now to perform task T1 and then do task T2, the total number of ways that we can do that is equal to the total number of ways that we can perform task T1 times the total number of ways that we can perform task T2. So let's see. We're going to select 3 white balls from 8 of them. The total number of ways we can do that is this. And here we're going to select 1 red ball from 4 of them. The total number of ways of performing that is this. Here we're choosing 3 white balls from a total of 8 white balls. That's the number of ways of performing task T1. Here we're choosing 1 red ball from 4 of them. That's the total number of ways of performing task T2. So to perform task T1, then do task T2, the total number of ways of doing that is this times this. And let's see what we have. This is equal to, here, we have 8 factorial divided by 8 minus 3 is 5 factorial times 3 factorial. And this is 4 factorial. 4 minus 1 is 3, that's 3 factorial, and then just 1 factorial. So let's see, this is equal to 8 times 7 times 6 times 5 factorial divided by 5 factorial times 3 factorial, and this is times 4 factorial, that's 4 times 3 factorial, that's just 1. So these cancel. 3 factorial, that's just 6. So these cancel. So this is equal to 56 times 4 equals 224. So the total number of ways then to select 3 white balls and 1 red ball is 224. And again, that's using our combinations plus our counting principle together. Okay, that's it for this video. Hopefully that makes some sense to you. Come back and join us in the next video. We're going to have another problem that involves combinations and permutations together in the same problem. Let's see how we approach that one.